All right, so here she's pouring in 10 milliliters of ethanol, right? During the break, we measured it out just right. And then she's going to take and pour in another 10 milliliters of water. And you would predict that there would be 20 milliliters of total volume, right? Okay. Let's take a look at it. How much we got there?
A little bit under 20.
Yeah, let's see. That is, wow, that's like 19. So we just did the experiment. And we got 19 milliliters. So now how are you going to explain that one? Okay. Well, here's what's going on. In the water graduated cylinder, right? Do I need to watch Sandy and be sure she's not going to shoot that when I'm not looking? In the water graduated cylinder, here's what we got. Oh God, would that not be bad? That's denatured, by the way. So here's what we got. We've got water, all right, and it is hydrogen bonded with itself, and they're being held together. Are you with me? Okay. Then we've got ethanol. Now ethanol, there's a CH3, CH2, OH, and then guess what's to it? There's an H, an O, CH2, CH3. Look at here. Do you see how that's held together? So what have we got? In beaker 1, or in graduated cylinder 1 that we just did here, we had an ethanol to ethanol hydrogen bond. Does anybody want to dispute that? And remember, a hydrogen bond is doing what? Is it sucking molecules together, or is it pulling molecules apart? It's pulling together. Look at here. Here we have a water-to-water hydrogen bond. So we're taking water, and it's attracting to itself water. Yes? Okay. And what's we got here? Well, we have a water-to-water. Do we not? Sure we do. We also have an ethanol to ethanol. Do we not? But what's the third component that is new? The new component is we have an ethanol that is bonded to a what? A water. Do you see that? So the new one is an ethanol to water hydrogen bond. Do you see how that solvent will contract? So there were these little bitty spaces that are not there no more. They've been compressed together. And this idea of non-additive volumes, that means normally you would be right. 10 plus 10 equals 20. That's normal. Okay? But when it gets to alcohols here, it don't work like that. Okay? 10 plus 10 does not equal 20. It equals 19. Because this third intermolecular hydrogen bond has made the solvent contract to a smaller amount. Does that make sense to you?
The volume changes.
The volume changes. That's correct.
It's contracted.
Because it's contracted. That's right. The volume has changed. It's not been additive. All right. There's more bonding there to suck the molecules together tight. Tight, tight, tight. Now, which one's going to evaporate the quickest? Ethanol, pure ethanol, or an ethanol-water mixture? Pure ethanol. Why? Because look how tight this is. All right? This is extremely tight compared to the ethanol. All right, yeah?
If we add them together, the mass is the same, it's just the value is less.
That's right. Yeah, mass has to be the same. And maybe we should have did it on the balance. That wouldn't have been too much trouble. But yeah, the mass has to be the same. Mass cannot change. Now don't get me wrong, maybe the whole time I'm up here talking, the mass will change just because there is some evaporation, right? But we're talking about in the time frame of the experiment, the mass cannot change. All right. How are we doing? So do you want to talk a little bit about alcohols while we're here? Right? So how is alcohol made? Fermentation, most commonly, right? And people fermentate all kind of stuff between grapes, and then they distill grape wine, and they can make brandy, and then they make beer, and they ferment yeast, and they ferment corn, and all this drama. Okay? So how is it that you can get a purity of 100% alcohol? All right? Well, the first thing is alcohol is given in what is called a percent VV. So when you go to the ABC store and they look up a value, it is given in a percent VV. Now what that means is this, is you will take the volume of liquid in question divided by the total volume of solution times 100. So, in, what's your first name again? In Alicia's drink, here's what she did. She had 10 milliliters of good old-fashioned ethanol, right? So here she is, a brewmaster or whatever. Now what was her total volume of the solution? 19 times 100. So I want to know what her percent VV concentration is, or percent volume. So that's going to be 10 divided by 19 times 100. 52.6%. Okay, 52.6% would be her cocktail that she just made. Now you would think that it's a 50%, right? Does that make sense? 10 milliliters of this, 10 milliliters of that. But they don't work with alcohols. Why? Because they have this non-additive volume scenario. Now, what's the proof? Okay. The proof is you're going to take that number and multiply it by 2. Okay. So 52.6 times 2. So that means her new drink would be 105 proof. Okay. Now just to give you something to put your hat on, most spirits that normal people would go about drinking, okay, like a rum or a scotch or a bourbon or a Jack Daniels, something along these lines, okay, is around 80 proof. But this here you can see is 105 proof, right? But she took 10 milliliters of pure ethanol and mixed that into a water up to 19 milliliters. Does that make sense? Okay. So what if you did have an 80 proof spirit? Okay. What's going to be its percent volume? 40% volume. That's right. And the proof term came from the old moonshiners that, as you may or may not know, I mean, well, it's just like going to the liquor store, right? You can buy a variety of different types of liquor, from the very, very expensive Grey Gooses and whatnot to the more cheap Mad Dog 2020 nights or whatever it is you guys do these days, right? Well, moonshine's the same way. You can buy a very, very expensive Elite, or you can buy some Bobo crap that'll get you through the night. They cost different per gallon or per quart. So they called it to prove yourself when they come to show moonshine, and what they used to do is take gunpowder and mix it with the moonshine and light it. An experienced moonshiner could tell the color of the flame, what proof he was dealing with. So then they know whether they're getting got or not. Does that make sense? All right. Now that has stuck, and it actually goes through. I mean, you can see here from an official chemical company, all right, where we've ordered this stuff here, it will say on it somewhere, unless of course it doesn't. It does say on it somewhere. Ethyl alcohol, where does it say? Why don't it say 200 proof? Am I just under the gun trying to be fast here? Well, it is 200 proof.